Alright, so here we go. This is section 5.1. We are getting into graphing sine and cosine functions. I don't have my little clicker today, so I'll be pressing on the laptop. You'll probably see that. Alright, so what are the purposes for this lesson? So today I'm going to, hopefully you're going to know the shape of sinusoidal graphs, another word for trigonometric graphs. We're going to figure out the characteristics of sinusoidal graphs, what they look like, and we are actually going to graph them. So those are the purposes. That's what we're doing in this lesson. Let's talk about sine graphs. So here is the equation for sine, so y equals sine x. If we look at a table of values for this function, so we pick some x values. Now I'm picking very specific x values. You should recognize these from chapter 4. These are your axes. So starting at 0, wait, I'll see if I can do it from your perspective. 0, pi over 2, pi, 3 pi over 2, and 2 pi. So just following that full rotation for me, depending on, I don't know how the camera's going to orientate. But starting at the positive x-axis at 0, moving up to the positive y, then negative x, negative y, back up to the 0 point. So if we plug these x values in, these are the y values we get out. And you should recognize this. Y equals sine x. This we've already seen before. This is what the sine graph looks like. You've probably seen this before. It's a periodic function, meaning it repeats. So at the end of the red lines, there should be arrows. And it continues on forever. So it's going to continue to repeat and repeat and repeat until infinity. So here's some characteristics that go along with this graph. So the domain, x is all real numbers. It keeps going to the left and to the right forever. The range, so that the lowest value is -1, the highest value is +1, which I just said there, max and minimum. That gives you your range. The period for this is 2 pi, or 360 degrees, so we're still going to jump back and forth between radians and degrees. But as you can see in this graph, I did radians, but that is a full rotation, is 2 pi. The amplitude, oh yeah, the blue arrow there, so that shows the period. It shows as soon as you've done one complete up, down, and back to the middle, that's the period, the time it takes to do that. Amplitude is 1, so where this is on the graph, from the midline to the maximum, or from the midline down to the minimum, that gives you the amplitude. For sine, your y-intercept is 0. You can see that on the far left of the graph. Your x-intercept is n times pi, where n is an integer. So your x-intercepts occur at every pi. So if you look at 0, there's an x-intercept. You look at 1 pi, there's an intercept. 2 pi, there's an intercept. 3, 4, 5, all of those times pi give you intercepts. And it's cyclical, so it keeps on repeating. We can do the same for cosine graphs. So y equals cos x. If we were to make a table of values for this, we can see how the x and y values compare. We'll use the exact same x values. Again, this is taken from chapter 4, looking at the unit circle, those different axes. We'll get different y values. So at x equals 0, y equals 1. If x is pi over 2, the y is 0. And this is confusing compared to last unit in that cos x, or cos theta, represents the x value. So if you're trying to compare it to the last unit, it'll be a little bit tricky to figure that out. The x is your theta. So this is what our graph looks like. So we start off at the maximum point at 0, 1, and then it follows a full rotation, goes all the way down, comes back up. It looks very similar to sine, except I'm starting at the maximum instead of the midpoint. Let's look at the properties. So domain, so x is all real numbers. Range, I go from -1 up to +1. So my minimum and maximum. So the period again can be from the middle point to the next rotation in the middle point, as we saw with sine. Here I can also look at from peak to peak. That gives you the period. You could also look at the minimum to minimum. You just need to figure out how long does it take to do one full rotation. Amplitude is 1, as you can see here. So going from the midline up to the maximum, that is your amplitude. Y-intercept is now 1 instead of 0. And your x-intercepts have also changed. They've shifted to the right. So that should, instead of actually being written as pi, it should be a pi symbol, but it's pi over 2, and then plus or minus a pi. So then you got pi over 2, you add pi, you're 3 pi over 2, and then 5 pi over 2, and then 7, and so on and so forth. Those will give you every single x-intercept. So those are the properties of sine and cosine. There's slight differences between them, but the domain, range, max, min, period, amplitude, those are all the same. Really, only thing that changes are your intercepts. Okay, so it can be confusing to know which one is which, but if you want to compare between when is sine and when is cosine, you can just remember this. Sine starts at the middle. They share the I in the middle of both of those, sine, mid, and cosine starts at the top. So there's an O in the middle of that. This is just something to help you to know, okay, which one's sine, which one's cosine. Sine, mid, cos, top. Let's try some examples. So given the graph below, here's a graph. Determine 4 other points with the same value. So I show a point there, and we are told this is at x equals 2 pi over 3, y is square root 3 over 2. We want 4 other points in this graph that have the exact same value. With the same value, I mean the same y value. So if I go like this, we can see here are the other points at which we have the exact same y value. Now we need to determine what the other ones are. The very easiest one is point 1. So this one here, I am just simply moving from the original point and I'm going backwards or to the left by a full rotation. And that full rotation is 2 pi. So all I'm doing is I take the x value, subtract 2 pi to get to where that point is. This is essentially a coterminal angle, but just looking at it from a graph perspective. So that's how I'd get the first point. The second point here is a little bit trickier, and in order to get this one, we need to think back to our unit circle. So I'll show you this graph here. So what this is looking at quadrant 1 and quadrant 2, and we're comparing between the red terminal arm and the blue terminal arm. Those both have the same y value. The y value being this root 3 over 2. If you were to look at your unit circle and you were to compare between 2 points that have the same y value, that is essentially what we're doing here. So the blue line represents the point we're given. This is 2 pi over 3. The point 2, which we're looking for, is pi over 3. So that's the other angle that would give me the exact same y value. Again, this is given on the unit circle. That is where you get these two angles that have that same y value. Next, we'll look at point 3. Point 3 and point 4 are going to be very simple now that we have point 2. If point 2 is pi over 3, if I want to get to point 3, looking at the graph, I am going to subtract 2 pi. I'm doing a full rotation to get back to that point. So here is your equation, pi over 3 minus 2 pi. We get negative 5 pi over 3. There's point 3. To get point 4, I'm going to do the opposite. So start at point 2, and I'm going to add 2 pi to get to point 4. So this gives me 7 pi over 3. So these are the 4 points for this that are at the same y value. So I got negative 4 pi over 3, I've got pi over 3, I've got negative 5 pi over 3, and 7 pi over 3. So that was looking at just the basic function. Now we're going to look at some transformations of our graphs. So amplitude, we saw amplitude already in the first ones with sine and cosine. The amplitude is always given as positive. You never write that as negative. And it correlates to the a value with our function. You remember back to all the other units previous to chapter 4, we dealt with a, b, h, and k. So amplitude is dealing with a. Conveniently, it starts with the same letter. So it should be easy to remember. Amplitude gives you your vertical expansion and compression. Let's look at a few examples. If I have a equals 2, or if I have a equals negative a half, let's see how that affects the graph. Notice with this, y equals 2 sine x, this is an amplitude of 2. Or it means we're doing a vertical expansion by 2. If I have negative a half as my a value, this represents an amplitude of a half, or vertical compression by 2, and we have a vertical reflection. These are my two graphs. The red line is 2 sine x. You can see here that my amplitude from my x-axis is 2, the difference between those. The green line is my negative a half times sine x. Negative, meaning the vertical reflection. Notice we're not going from the midpoint up, we're going from the midpoint down. That represents your vertical reflection. And you can see the amplitude is a half. So it goes, the minimum is negative a half, the maximum is a half. So that's what that looks like. The next thing we're looking at is the period. This correlates to our horizontal expansion and compression, meaning it's looking at the b value. So let's take a look at a couple graphs. If I've got cosine 1/3 times x, and I've got y is cos 2x, comparing these two equations, we've got cos 1/3 x. You've got a horizontal expansion by 3. Remember, b values do the reverse. So 1/3 means it's expanding by 3. And when I've got cos 2x, it's a horizontal compression by a half. So graphing these points, red line is cos 1/3x. This is our horizontal expansion by 3. Notice the period is now 6 pi. Originally, for a cosine graph, the period is 2 pi. Now it's 6, meaning we've expanded by 3. The green line is our horizontal compression, and note with that the period is now pi instead of 2 pi, so we've compressed by half. So this is how the b value affects our graphs, is it's expanding and compressing in the horizontal direction. So in general, if we're given some equation with a b value, the period is going to be 2 pi divided by b. Whatever that b value is, the period is 2 pi over b. If we're talking about degrees, it'll be 360 over b instead of 2 pi. Most of the graphing is going to be in radians, but if you were given degrees, it would be 360 over b. Might want to add that in the notes. I don't think I have it in the PowerPoint. Nope, I don't. So you'll want to add that on there. Okay, so let's combine these two. We've got sine equals negative 3 sine 1/2x. So with this, we have got a amplitude of 3, because a value has a 3 in there. We're going to have a vertical reflection as well. The period is going to be 2 pi over b, b value being a half, so the overall period is going to be 4 pi. I said vertical reflection already. Now, with this, what might be confusing is how to figure out the points. So instead of taking the original sine and cosine graphs and trying to move the points, I'm going to show you a different way how to do this. And what we first need to do is we first need to figure out how to make the divisions on the x-axis, because that's going to be important. I need to be able to represent a point exactly where I want it on the graph, and this is how we're going to figure it out. So to get the divisions, we're going to take the period divided by 4. And that's going to tell me, okay, I have the starting point, and then one division, I will move to the next key point. So the key points with this would be midline, peak, midline, trough, midline. So going from middle, max, middle, minimum, back to the middle. Or max, middle, minimum, middle, max. They all start with M. That's going to be confusing trying to listen to that. But you follow through that in the whole rotation. So in this case, the period divided by 4, so 4 pi divided by 4 gives you pi. So when I graph this out, notice I have set my the graph, the divisions on there by pi. So I start at 0, then I've got pi, then I've got 2 pi, then I've got 3 pi, then I've got 4 pi. And at each of those divisions, that's where I'm putting a point. So because this is sine and it has a vertical reflection, I go from midpoint, move over a division of pi, I'm at the minimum. Move over another pi, I'm at the midpoint, another pi, I'm at max, another pi, I'm at the midpoint. So that's how you are going to be graphing these. There should be 5 points you're looking at, where you start from, and then 4 key points to get back to that same position. Don't worry, you'll see lots of different graphing examples. You'll be able to figure that out pretty quickly. Let's try it again. So now we've got a cosine graph. So this is 2 over 3 cosine of negative 4 over 3x. I could have written this as negative 4x over 3. It doesn't matter how you place that out, just so you recognize what's going on. Let's look at our characteristics. So A is 2 over 3, which means my amplitude is 2 over 3. The period, 2 pi over the B value, which is 4 over 3. Notice I just used the positive value because having a negative period doesn't make sense, just like having a negative amplitude doesn't make sense. We just represent those as positive values. Here we've got a horizontal reflection. So if you think about cosine, it starts at the maximum and then goes to the minimum. And it does that on both sides. If you were to go back to your cosine function that we drew, it always is going to be symmetrical on that y-axis. So that doesn't actually make a big difference. Let's figure out our divisions, how we want to split up the x-axis. So take the period, divide it by 4. So 3 over 2 pi divided by 4. This gives us 3 pi over 8. Yes, that's not a very pretty number. However, when we graph it, it doesn't need to look pretty with the points on the x-axis. But by setting those values as 3 pi over 8, then 6 pi over 8, then 9 pi over 8, then 12 pi over 8, we get this nice graph. And our horizontal reflection, as I said, didn't make a difference to this. But these are, well, this is what the graph looks like. Okay, so we're done. That is the first section of chapter 5. Hopefully you will get used to getting back into graphing again after a chapter of not graphing. And just as a warning, we will be getting into H and K next lesson to combine all of those things together and work on these sine graphs. So that is the first section. Okay, now for the after lesson video part. A behind the scenes thing with this. So I am actually making these videos a year after I made all the other ones. Due to COVID last year, I did not finish chapter 5 in the previous year. So now this year I am getting back into this. And so I'm figuring out what I want to do now for this part. And so I thought with this, what I would do is something fun. I'm going to describe some of my favorite movies with a bad description and see if you can guess what that video is or what movie that is. The first one is all about a farm boy who dreams of being up in the stars, and he meets a smuggler who apparently has a really fast ship, and they end up rescuing a princess and then blowing up a big object that looks like a small moon. So that is the description of the first one. If you have guesses, let me know in class, and I'll let you know if you're right.